How do you combine different data? If you have a whole bunch of measurements of some parameter and they all have the same errors, then you just average them. We've seen that before. But what happens if you have different measurements of something but they have different uncertainties? So for example, let's say you're trying to measure the expansion rate of the universe, and you might have a measurement made using supernovae, and you might have a measurement made using the microwave background, and a measurement from baryon-acoustic oscillations, which has big error bars, and you might have several more measurements with different techniques. Some have very small error bars, and some have enormous error bars. Now you don't want to just average all these things, because averaging the numbers which are crap, the ones with big error bars, with the ones that are good, with small error bars, will just make things worse. Your net result will have more noise than if you'd just taken the good data points. So one thing you might think would be a good idea would be just to take the good data points. You might just average those three because they've got small error bars. But nonetheless, these 2 points, they're not very useful, but they are telling you something. They're not telling you a lot. The way you do this is by using weights. You don't count all the points equally in your average. In fact, every point is given a weight which is proportional to 1 over the uncertainty of that point squared. So something like this is a big uncertainty. It'll be 1 over that big uncertainty squared, so it'll give a small weight, whereas the ones with small uncertainties, 1 over the small number squared, gives them a large weight. So what this means is this might actually count as 3 points, whereas that might only count as half a point. And then you can calculate the average, fit a line, do whatever you like. But each point, instead of counting each point equally, you count each one according to 1 over the standard deviation squared. This is called inverse variance weighting. And it turns out to be the best way to do it if your errors all follow the normal distribution. In general, you might not use this precise form of weighting, but some way of counting the points with small error bars for a lot, and those which have large error bars for not very much, some form of weighting is a good general practice.